A little more graphing with 9.4 today. A couple more things going on with shifts and movement than we had on Friday, but we will have some of the similar things going on. So just like before, what we're going to be basically looking at is functions that are in this format where my left and right shifts are going on in the denominator, also my vertical asymptotes. And then my horizontal asymptotes and my up-down movement are going to be occurring at the end. So with these, without even typing them into the calculator, we should be able to get an idea of what these 4 bits of info are going to be for us. So, without further ado, on number 1, what shifts do I have? Represented by the -4 and the -1 here. Okay, so we're at right 4 and down 1. And again, our up and down shift always directly correlates to the horizontal asymptote because both of these on the parent graph start at 0. They start at y equals 0 and x equals 0 unless there's movement. So a down 1 means my horizontal asymptote would also move down 1 with the shift. And we talked a little bit on Friday about the relationship between my horizontal asymptote and my range, which basically tells me every real number would be included in this, and that's with our double barred R here, except for where that asymptote is at. And we're going to take a look at this one graphically in a minute just to kind of see that and remind ourselves again. But those two are always going to go together. And then my vertical asymptote always is going to move with any left or right shifts. So this one would end up at 4. Since we went right, it's positive. And that always directly correlates with my domain, which would be all reals except that value at 4. So let me get this out of the way. We won't do this on all of them, but we'll take a peek here. And one thing I will mention, for those of you that are still either back with Fridays or something like that, even though they're not going to be written on problems a lot of the time, if you go to put these in the calculator, you have to have those parentheses around the x minus 4. Because if I forget, the calculator is going to think I want to do 3 divided by x and then subtract 4, and that's not at all what we want to do. So anytime you see those pluses or minuses working somewhere here like this, maybe give yourself that reminder, put the parentheses around so we don't have any issues. So I look at the graph, and I can see why some of these things are. I can see my vertical asymptotes over here at 4. Bless you. And then as far as my domain goes, it's going to keep going forever to the left, forever to the right, except at that one point where my graph would stop. Horizontal asymptote's the same thing. I noticed that it shifted down. It's basically running right along this line at -1, but it goes down, down, down forever, up, up, up forever, except that one value here where it's never going to touch. That's our idea with these, but it's nice when we can do it without the graph because it just kind of slows us down otherwise. All right, number 2, what shifts do we have working? Okay, left 3, up 2. So what's my horizontal asymptote going to be? Okay, y equals 2 because we went up 2. Up-down shifts always go with my horizontal asymptote, which in turn always means it's all reals except where my asymptotes are going to be. What about my vertical asymptote? Okay, x equals -3. And that's one thing I will give you a heads up on. When we get to a quiz on this, if I list something down like this, when you write your horizontal and your vertical asymptote, you have to put x or y equals with it. I have to know that you know the difference. So if you just put like horizontal asymptotes 2 and vertical asymptotes -3, you're going to get dinged. So make sure on these two you're getting your variable terms with. All right. One more to play it safe. Number 3. Shifts. Right 3, up 4. And again, it's that left-righter that's going to be my vertical, but I'm doing my horizontal first here. So up 4 brings this up to 4 and puts my range at all reals not equal to that asymptote value. And then again, my vertical always goes with my left or right. And it'll go hand in hand with that vertical asymptote. So again, that part I'm hoping should be pretty easy for you at this point. It's just keeping, those parts straight, what goes with what. Now, there's going to be a few things we're going to add in today, some other things we're going to find besides asymptotes and domain and range. So, to help us out with that, we've got a little box here. And you will, when we get to the next quiz, we're currently working on putting together I'll call it this for lack of a better word, a cheat sheet that sort of goes over some of these things on there, which you'll be able to use on the quiz and you'll be able to use on the unit test. So don't think you've got to have all of this stuff memorized, but it's nice to know, so it's a little bit easier for you. So we're going to be looking for X-intercepts are the zeros of the numerator. In other words, you set the numerator equal to 0, figure out what those values are. Those will be your X-intercepts. My vertical asymptotes are the real zeros of only the denominator. In other words, set the denominator equal to 0. We find our vertical asymptotes. Holes might be a new thing to you. You're going to have a graph, and just right in the middle of it, there's going to be this little open spot, and we'll see why that is here in a minute. A little factoring involved, but we'll get there. And then the horizontal asymptotes are found by comparing the degree of your numerator and denominator. So we're going to get to play with all of these today. We'll be doing a lot of flipping back and forth here. So for your horizontal asymptote, if the degree in the denominator is larger than the degree in the numerator, you'd have, so like let's say you have something like this. If you had something like, I want to make sure I don't get into crazy shifts here. Something like this, okay, my degree in the numerator would be 2. My degree in the denominator would be 1. So I'd end up with a horizontal asymptote that doesn't move anywhere. It's still going to be at 0. If it's what we call top-heavy, I just switched those around. Bless you. I did. I'm a silly man today. I just flipped top and bottom heavy around. Okay, let's fix. As soon as I wrote it, I'm like, degree in the denominator, Harty. The denominator, the one on the bottom. Oh dear, bless you. Yeah, that's much better. And the degree in the denominator is larger. Okay. If the degree in the numerator is larger, then there's no horizontal asymptote. And there's this fancy thing that's called an oblique asymptote that runs at a slant, but we're not going to deal with those in here. That'll get covered when you hit pre-calc. It's just something we wanted to introduce you to a little bit. But for now, we're just going to call it no horizontal. So no oblique issues. And then equal weight is if your numerator and denominator are the same. So like if I had something like 2x minus 3 and 3x plus 4, it's just going to be the ratio of my lead coefficients. So my horizontal asymptote in this case would be at like y equals 2/3, because you would just take the coefficients of those x terms and divide them. And a lot of times you'll be able to see these on the calculator. So if you happen to forget something, you might be able to get fortunate and look at it that way. But again, all of this is going to be available on one nice sheet that we're going to be able to use. So, for the time being, we'll do a little back and forth flipping here as we start to work our way through some of these. So I start and I go, okay, first thing on here says we've got an X-intercept. Remember, that's just setting the numerator equal to 0. And any real number values I get would be my x-intercepts. So like here, I am going to have an x-intercept at -1. And at least at the start, if I want to literally see how this works, that is never a problem. Again, I'm going to put parentheses around these so I don't get any weird, funky things that I don't want. So look at the picture. Picture's kind of interesting. My x-intercept, remember, would be where my y value, when I get back up here, is going to be 0. So sometimes I might even be able to take it off of the chart. If I can't, which could happen, it could be a decimal value sometime. Remember, whenever you're on your graph, if we kind of take a look back to yesteryear, we can do second calc. Remember when we were doing this all the time with things? And an x-intercept is just a fancy way of naming a 0. So when we were looking for zeros before, we always had to do things where, like for instance, I'm looking here and I'm like, okay, notice if I start scrolling back and forth here, how my y value, because I can visually see it's in here somewhere. My y value is negative right now, but if I start going this way, it's positive. Where we trapped it. So I see my y value positive. I'll hit enter. Then I'm going to hit right until it gets negative. See, now it's negative. And I'm going to hit enter twice. And I can also get my 0 that way if it's some funky decimal or something. Okie dokie, thank you. So that's one of the ways that we can kind of, multiple ways of finding the same thing. But if I can get it off the chart or I just see it, that's the best. My y-intercept, if we get my graph going here again, remember, is when my x value is at 0. So if I just hit trace and then I hit 0, what it'll do is it's going to find the y value when x equals 0. That's what I want. If there is one, it'll tell me. So my y-intercept is at -1/4 or -0.25. So again, the x-intercept, either find the 0 and trap it, or use your chart where y equals 0. And the easiest way on the y-intercept, if there is one, is using the trace and 0. Okay. Now I should be able to figure out these other two things on my own. Vertical asymptote, be careful. There's a value here in front of it now. So I'm just going to set my denominator equal to 0, because that's one of the things it mentions over on the front page of the notes. So if I go ahead and solve this for x, that's where my vertical asymptote is. And if I look at the picture at the same time, I see. Yep, there's my asymptote. It's at 2. Okay, that makes sense. Now, horizontal might not be as obvious. I have this feeling as I'm looking at this, it's not at 0 because it looks like that's above it a little bit. So if I flip back over to the front for just a second, I'm like, okay, horizontal asymptote. My degree is 1. It's just my largest exponent. So they're equal in size. And it says here, if they're equal weight, the horizontal asymptote is the ratio of the lead coefficients. In other words, take the lead coefficients of each and just divide them. Okay? So my lead coefficient here is 1. My lead coefficient here is 2. So my horizontal asymptote is going to be at 1/2. Like, all right. It doesn't change anything with our domain and range, though. We're still going to find that the same way. My domain still goes with my vertical, and it's going to be all reals except for any asymptotes. Range, same thing. All reals, except for where my asymptotes happen to be. And when I go to graph these, I recommend the same thing I did before. Get those asymptotes in there to kind of give you a little guidance. We're not going to look for complete perfection on everything that we're graphing with this, but we want to be somewhat accurate. I mean, if you say there's an x-intercept at -1, we want to make sure there's one there. Y-intercept at this -0.25. And let's look at the picture here. Okay, so I see my picture. Basically, I see I'm going to have branches in the first and the fourth quadrants, but it doesn't hurt to let the calculator give us a little bit of help too with these. So I've already got my -1, 0. I got this guy right here. And I got 0, -0.25. I got him. 1, -1, because that guy, yeah. And then I get into my error, so I remember again, okay. So I got my branch, and then I'll just start up again here on the other side. 3, 2, 4, 1.25. If I want to get one more point in, that's fine. 5, 1. And again, the arrows keep going forever on both sides. Don't just connect a few dots and leave it. They've got to go, go, go with those branches. That should probably be the easiest part, just plopping some numbers down. It's going to be trying to figure out some of that other information that can get a little challenging sometimes. But the biggest thing with any of these is just to get used to how you're finding the parts. X-intercepts. Set the numerator equal to 0 and solve it, or in this case, factor it as best you can. So I've got, let's see here, -3 and +1. Set those each equal to 0, means I'm going to have an x-intercept at -1 and at 3. So I can put those in right away if I wanted to. Now my y-intercept I may not find right away, so I'm going to leave that for a second. Vertical asymptotes, again, set your denominator equal to 0. And whether you factor this, which is normally what I would probably do, or I guess you could just add the 4 and then square root it. That would work too. So I have vertical asymptotes, multiples this time, at -2 and +2. I notice the degree of my first terms is 2 on both of these. So it's equal weight, and just like it was up on number 5, that means we just divide the coefficients. 1 divided by 1 gives me a horizontal asymptote at 1. Domains, you're like, dang, we haven't even graphed anything yet, got all this info. My domain goes with my vertical asymptote, so all reals not equal to -2 or 2. And at this point, this is where I would go to the calculator to get my y-intercept and to just kind of help me with some of this other stuff. So let's see here. I'm going to go ahead, I'm going to get my asymptotes drawn in. I know, it might be a little bit of a risk before I've looked at the calculator even, but I'm feeling good that I've got this under control. Might help me a little bit once I start doing this in a second too. All right, swing this over. All right, I'm going to play it safe. I'm going to put my whole numerator in parentheses and my denominator as well, just to make sure that I get that separation. And let the calculator know I want the whole numerator done, the whole denominator, and then we can see what it looks like. Ooh, funky. Okay. So things I notice right away. I notice my 2 vertical asymptotes at 2 and -2. I notice that it looks as though my calculation of a horizontal at 1 looks pretty good. And it looks like we got a pretty good chance that at 3 and -1 we have our X-intercepts. We're going to find all that stuff out here in just a second. Y is 0, X is 3, that's a good thing. Y is 0, X is -1. Got my intercepts. Good. My Y-intercept, I even get that one this time. When my X value is 0, my Y-intercept is at 3/4. So then I'm just going to take a quick peek here again, see what this looks like. Like, this looks kind of strange. Haven't seen this before. Now, here's one thing that gets a little more complex, because I start looking at my numbers and I'm like, okay, let me start. Let's come back to this again. Now, why is this not letting me go where I want? There we go. So when I start to get some of my values that I'm going to put in here, typically I start to hover around where my asymptotes are, my vertical ones. So if I'm at -2, I'm going to go to the left of it here a little. So -3, 2.4, and I start to notice it's coming back down, and it's going to come down toward where my horizontal asymptote's at. And it's going to hug that asymptote, but it's never going to go. It's not going to go through it. And I'm going to do the same thing over here on this one. It starts at 2, so I'm going to scroll down to 3 here and start writing a couple of values down afterwards. So 3, 0 I already had. 4, we're almost up to a half. And I start noticing that's going to come really close to hugging the one over here. It's the middle that's a little bit funky now. Because when I look at the graph, I'm like, well, wait a minute. We say there's a horizontal asymptote at 1, but my graph's going to go through it. Is that right? Did I do something wrong? No, you did. Sometimes when you get that middle term, you're not always going to be able to stop. It might just go for these outer 2 pieces. That part can be tricky to deal with sometimes, but we do. So let's see here. So we have -1, 0. 0, 3/4. We had that one already. 1 is just above 1. And then we get this kind of funky looking, almost S shape going through here. So for my outer branches, my asymptote's still going to apply. But when we get that extra piece in the middle, sometimes we're going to have that value going through. It doesn't like playing by the rules that everybody else does, which is why having the calculator to get some values is a good idea. So we can get all sorts of funny looking things going here. And if something just doesn't quite seem right, or I get blown along, because sometimes I get slightly excited about these things and don't slow down, tell me, be like, hey, you need to stop there for a minute and be like, okay. All right, are we doing okay so far? All right. So let's get all our info going here on 7, then we'll kind of see where we're at here. My domain, ooh, it's already factored for me. That's nice. Okay, that'll get me my vertical asymptotes pretty quick. So 1 and -4, which also quickly will give me my domain. So I'll go ahead. I'll get these drawn in. Now, the horizontal asymptote, that can get a little more interesting. I may even want to look at this for a minute with it written back out of its factored form. And here's why. Looking at it this way, it reminds me my degree down below is greater than it is up top. So here, we're bottom heavy. So if you look back at your front sheet, it says when we're bottom heavy, if the degree in the denominator is larger than the degree in the numerator, which it is, the horizontal asymptote is at y equals 0. So we will use that to give us an idea here again of what's going on. If my horizontal asymptote's at 0, my range is at all values but 0. My zeros, and again we talked up above about how 0 and X-intercept are interchangeable, set my numerator equal to 0. Shoot. So that's going to be at -5. Talk about that issue here in a minute. And then we're ready to get our other stuff. Now, one thing I will warn you about when you're typing this in the calculator, and this happens whenever you get something working like this. You might either want to type it back out into its unfactored form, or otherwise, here's the other thing you will have to consider. You're like, wow, like double parentheses? Do I really need all that? Yes, and here is why. If I don't put those in, the calculator is going to do x plus 5 divided by x minus 1, because it's going to follow order of operations, and then it's going to multiply it by that. Well, that's not what I want. So when I'm doing those and I have multiple quantities in the denominator, I have to surround them with an extra set of parentheses, because that's telling the calculator, okay, I want you to multiply these two guys, and this whole thing's the denominator. That's what the second set's doing for me. So then I look at this and I'm like, ooh, 1, -4. So there's my verticals. Looks like we're basically hugging the x-axis here, which goes along with a horizontal asymptote of 0. My y-intercept, let's see here. So x equals 0, my y-intercept is at -1.25. So we got a dot there. So I start to look like I did before. Let me swing this over. I'm always looking just to the left and right of my asymptote. So since I see this 1 here already, let's start here. So 2, I'm just above 1. And then I kind of move my way down. And I'm like, that's normal. Because this would hug here. That looks good. I'm going to skip the middle for right now. I'm going to come back over here to the left. And then we'll come back. Okay, so we got our -5, 0. Then we start looking at the other ones. We're like -6. Wow, we're barely below here. Barely below. And I'm not really seeing, you're like, it starts coming back up towards 0. Wait a minute, it starts coming back up towards 0. Let's look at this graph again. That's weird. It's coming back up. It's not going the opposite like these normally do. What's the deal with this? Because now this one looks like it's going up again. When you get that bottom heavy working, sometimes that's going to happen. And that's why I can't just assume and start drawing pictures like people want to do sometimes. Because then I look and I go, okay, well, let's see what's going on in the middle here, like between -3 and 0. Because this is kind of strange. -3's at -0.5, okay. -2 is at -0.5, that's kind of weird. -1 is at -2/3, and then my 0 that I already have. What? Let's look at this again. So this actually, which is why whenever we try to make an assumption, we can get ourselves into all sort of dilemmas here. And I can't just assume what I see on the calculator itself tells me the whole story. Because some of you, if you just were scratching, would make this look like a heart rate monitor at the hospital and would just draw and kind of scribble something like, no, that's why we're so worried about making accurate points. So we can see where those values go and kind of let the calculator help us with it. Like, this is strange enough already. I got one more strange thing to throw out there now. It's called a point discontinuity. We just call it a hole. And basically, there's literally going to be a hole in the middle of your graph, in the middle of one of your branches, or it may even look different from that. If you can ever take one of your functions, and when you factor it, it's almost like you could cancel these out if we were trying to reduce. Whatever that value is that you could cancel, or that they have in common, if you set that equal to 0, that's where your hole is going to be in your graph. Your calculator will bring it up as an error message, which will make you possibly think it's an asymptote, but it wouldn't be. It would just be a hole at that point. But that only happens when you have that same factor in the numerator and denominator. Because otherwise, if it were like this, it just would be a vertical asymptote at 1 and -3. Another thing to be careful of. So, like we said, that graph would have an asymptote at -3 and a point discontinuity, a hole at 1. Like, oh my gosh, another big old honking box of stuff. So, if we have a factor that goes in the numerator denominator, it's going to be a hole there. If it's in the denominator, but it doesn't cancel with the numerator, that's what this is a fancy way of saying, you still have a vertical asymptote. Sort of like what we were saying on the other side. Nothing cancels. We work that. Okay, 0 is make the numerator 0. We talked about that. Y-intercept when x equals 0. We talked about that. And then we talked again about top heavy versus bottom heavy. So we've got this chart to work with again. So I just want to work through a couple last ones here. Yep, and then we should be good to go. So, number 8. If you can factor, you always should. So let's see here. We got x plus 7x minus 1. X minus 1. I notice a couple of things right away. One, and let me explain this. We're still trying to find asymptotes, okay? But sometimes they say end behavior in front just to kind of be a descriptor of what's that asymptote making your graph do, bless you, forcing it in one way. It's not like the end behavior we're used to talking about. It's just another way of saying it's an asymptote. So, and like it says here, basically it's just a way of saying horizontal asymptote in a really fancy way. So for our purposes, what do I notice right away? Common factor. So if I set x minus 1 equal to 0, I have a hole at x equals 1, which means whatever my graph looks like, there's going to be a little open spot when x equals 1. So I look, I'm like, well, wait a minute. If that's a hole, I don't have anything left in the denominator to work with. It's true. I have no vertical asymptote this time. And if I have no vertical asymptote, the only place I'm going to have a problem is at this hole. So my domain never can have a value that either has a hole or a vertical asymptote. Sometimes we may have just one or the other. My horizontal asymptote, this time we are top heavy because the degree of my numerator is greater than the degree of my denominator. No horizontal. Because my P is greater than my Q, or my numerator is greater than my denominator. You're like, wait a minute, no vertical or horizontal asymptote. What the heck does this thing look like? Well, let's find out here. X-intercepts, set those equal to 0. So I got one at 1. And I've got one at -7. And the y-intercept we're going to see in a minute, because I want you to see this graph. And at first, if you were doing this on your own, you may look at this and go, yeah, I typed something in wrong. No, you didn't. I'm going to leave it in its original form. I could put it in the factored form, but we've seen how that can cause issues. So I'd have to have my double set of parentheses again. Like, Harty, it's a line. Yes. It acts just like the line x plus 7. It has a y-intercept at 7, if I look at my chart. Oops. 0, 7, okay. But notice when you get to x equals 1, it says error. That's where the hole is. You're like, well, wait a minute. It said here that I have an x-intercept at 1. Right, but that hole is going to cause a problem there. So you're like, basically, I'm just graphing the line x plus 7 because as I put these dots in, for what I see in the chart, it's just making a line. Yes. Except when you get to 1 and that error is there, you make a nice open hole because that's where my 1 value isn't going to be. So all of a sudden we go from a hyperbola to a line with a hole. Weird, but true. So we look at that and we go, okay, I might be able to be all right with this. One more just to feel confident with some things, and just to give you a heads up, tomorrow is going to be a work day. So if some of you are looking at, oh my gosh, how are we ever going to get this done for the homework check? You're going to have some time tomorrow. I'm not going to rattle forever. So I get to this last part, and I always want to look for things that I can factor. Okay, denominator looks factorable. So I will do that. So first I notice X-intercepts. If I try to set x plus 1 equals 0 to 0, I run into a little bit of a dilemma. I can't square a number to get -1. Well, I could use I, but you can't put I on a graph. So if it's not factorable without getting an imaginary number, I just don't have any. Y-intercept we'll talk about in a minute. My end behavior, equal weight, divide the coefficients. Y is 1/3. Holes, not this time. Because remember again, for there to be a hole, I would have had to have had a common factor with these. I'd have had to have had another x minus 2 up here somewhere, and I don't. So I don't have a hole this time, but I do have vertical asymptotes. I have one at 2, which is obvious, but don't forget the one that's lurking. You also have to set that 3x equal to 0. So there's 2 this time. This is going to be one skinny looking graph with asymptotes this close. This ought to be interesting. So my domain cannot go through 0 or 2, but everywhere else it's good. So I shift over here. We're almost there. Like I said, that's why we like getting some work days in here and there. Again, anytime you start seeing plus or minus, there better be parentheses working or the calculator is not going to do what you want it to. Well, let's take a peek here first. Asymptote, asymptote. Looks like it's going to be going like this, and one of those guys in the middle. Okay. So let's check this out. Looking around the asymptotes first, what do I notice? I notice that my value is just above the point that I need, but I've got to watch and see. So 0.22, and then I start coming back towards this, and I'm like, okay, well, I've got my error here. What about -2? I'm at 0.20. So it's actually coming down a little bit. Then it goes back up here, and it's really hard to see, but I'm going to get there. So I might have to keep looking and go, okay, looks like that's going up. which would make sense. Then I work into that middle region, which we'll talk about in just a second here. You're like, now what do I do? There's only one value here. What am I going to do to fix that? Well, there's a couple things I could do. I could change my table. Because you know my table always goes by ones, and if I hit second window, I can change it. What if I want to look like it every half instead? Maybe I can get me a little bit more of an idea of what's going on here. So like for instance here, okay, so add, oops. There we go. And I can start to see, by getting that extra half in there, that these are both going to be coming downward. And it also helps me going the other way to see that this is going to curve up. So if you need to change your table view a little bit, you know, shorten things a little, so when I'm looking at these, I get a little more accurate of a view of what's going to actually happen. Not a bad thing at all. So you do not have to do the back sheet of this, 11B, you do not have to do. I made a boo-boo, so it's going to be your gain that I did a boo-boo on this. So your job is to start working on that 9-4 stuff. There'll be some work time tomorrow. I might throw one little thing in, but it's not going to be something new with notes or anything like that. And